When we try to find the compensated demand, what we're really doing is trying to find the least amount of money that we need to give to a consumer in order to get them back to the reference utility level. So what we're doing is really solving the cost minimization problem. So let's suppose you have a target utility level, U bar, and the prices are P1 and P2. So your expenditure then, if you buy the bundle Q1, Q2, is P1 times Q1 plus P2 times Q2. So how much money do you spend on good 1? Well, if you buy Q1 units of it, and each unit costs P1, altogether you're spending P1 times Q1 dollars on good 1. Similarly, you're spending P2 times Q2 dollars on good 2. So altogether you're spending P1 Q1 plus P2 Q2 on the two goods, on the bundle Q1 Q2. So your expenditure is the sum of P1 Q1 and P2 Q2. So if you want to get to the utility level U bar as cheaply as possible, then the problem that you're solving is to minimize this expenditure P1 Q1 plus P2 Q2, subject to the constraint that your utility level is exactly equal to U bar. So you want to pick the Q1 and Q2 such that Q1 and Q2 give you the utility level U bar, and the bundle Q1 Q2 minimizes your expenditure, which is P1 Q1 plus P2 Q2. So this minimum value is the lowest income that you would need to have in order to get to this utility level U bar. And we're going to represent that by E of P1 P2 U bar. So the expenditure needed at the prices P1 and P2 in order to get to the utility level U bar is E of P1 P2 U bar. So what does that look like? Well, when we were trying to maximize the consumer's utility, given their income, for fixed income, what we did was we fixed a budget line, and then we said, what's the highest indifference curve that you could get to? Here, what we're going to do is kind of the dual exercise, which is to fix the utility level. So we fix the indifference curve. We fix this indifference curve, and we say, what is the least amount of money you need in order to get to this indifference curve? So let's start with, for example, E3. So there's some amount of money that would give you this budget line E3. Again, we fixed the prices P1 and P2. You can certainly get to utility level U bar. For example, this bundle here. In fact, any bundle between this point and this point, all these bundles give you at least U bar. And in particular, this bundle and this bundle give you utility level U bar. However, you don't need that much money. That's not the least amount of money that you could have in order to get to U bar. You could do so with less money. For example, if we took away a little bit of money, you'd have this budget line, and this bundle would both get you to the utility level U bar, and they're both cheaper. So E3 definitely does not correspond to the lowest amount of money you need to get to U bar. What about E1? Well, no bundle on the line E1 gives me utility level U bar. They're all too low. So E1's too low, E3 is too high. What about E2? Well, E2 is just right. There's this bundle here that gets me to the utility level U bar, and we get the familiar condition of tangency. The budget line is tangent to the indifference curve. Now the expenditure function and the compensated demand are actually quite intimately related. If we take the derivative, if we solve for the expenditure function, and we take the derivative with respect to the price of good 1, that actually gives us the compensated demand for good 1. This is called Shepard's lemma. We're not going to prove it in this course, but you'll probably see it in Micro 3, or if you go further and take, let's say, Micro 4, you'll see it in a more advanced course. But this relationship is between the expenditure function and compensated demand is called Shepard's lemma.